just kind of walk us through how the broadcast industry really initially relied on SDI hardware and then what made it such a foundational technology for so long.
So the industry's been on SDI since probably the mid to late 90s. I'm assuming it's kind of when it started to pop up a little bit early 2000s for sure. And it all kind of goes back a little bit farther even to analog, where on analog, the technology at the time allowed the propagation of RF. And when you deal with anything on cables, it all comes down to radio frequency or RF transmission on a copper cable. It's actually the fundamentals of it. That's what it was in analog, and SDI kind of relies on that a little bit too. So the hardware at the time had the ability to receive, route, and transmit RF signals down coaxial cable to be able to send signals through a facility. Now, those signals could be plugged into a piece of gear to be able to process it, or you can take an output of a camera and plug that cable in to be able to be routed into the infrastructure. But it was always about, in the analog days, taking this RF modulated signal, plugging it in, and routing it and transmitting it throughout the entire facility. Now, SDI just took that the next step. Is SDI because the consumers wanted better. They wanted something better than analog television. They wanted higher resolution. They wanted better colors. They wanted better audio, things you couldn't do in analog at the time. So they were able to take the analog video, take the analog audio, convert it to digital, and then they were able to do higher resolutions like 720p and 1080i, and even now we're doing 1080p and UHD and so forth. Mm-hmm. So we needed to be able to make that conversion, so we had to go to digital, which is what SDI stands for, Serial Digital Interface. But they wanted to use the same infrastructure they had. And honestly, the technology at the time only allowed to use the same style of infrastructure. So you have a camera, you plug in a coaxial cable. Now, maybe with a digital, we're able to do fiber, but still, for the most part, it's a coax copper cable. You plug it into the camera, you plug it into a router. The router is able to send that through your facility. Or if you need to have a piece of gear that processes it, adds a CG or does some kind of video processing and so forth, you plug it into that box. The output of that box gets plugged back into a physical router, and you go on your way.
So it sounds like those are the main challenges of some of the inefficiencies that you might talk about when you're talking about SDI and as content demands grow then, right?
Yeah, that's exactly it. Is you always have this one-to-one relationship, and it's also a physical relationship to the devices that create, consume, or modify media, and how you tie those workflows together. And also, a lot of infrastructure, even today, that's relying on SDI, still has limitations to how big you can build them. If I have a facility where I need to take a couple thousand inputs, I physically can't do that with SDI. We can't make the routers that big anymore. I mean, we always could, but it was very cost prohibitive. Mm-hmm. So the SDI infrastructure, as we know it, the bottleneck and the inefficiencies comes to the one-to-one relationship of one piece of media goes down one cable that goes into one router and so forth. It's a very physical domain. Everything physically has to be plugged into a physical device to physically process it, to physically transport it. It's always been the challenge.
So what was the tipping point that led the industry to exploring IP workflows, and when did that come about as an alternative?
Some of the first IP workflows came out under proprietary standards, and I'm going to say this has to be probably 2012, 2014-ish time period when we started to see the first IP routers pop up. And it was the very tip of the pyramid content producers. Things like ESPN, NBC, Disney, BBC, things like that. People that generate massive amounts of content to do multiple productions at the same time and feed hundreds of channels of video distribution at the same time. And their requirements went beyond what we could do in SDI. SDI's traditionally had kind of a limit of around 1,100 inputs to a router and 2,000 to 3,000 outputs for a router. That was always kind of the physical limitation to what we can build in traditional hardware.
So how did standards like SMPTE 2022-6 or even ST 2110 enable broadcasters to virtualize their resources?
Well, so those, considering the industry was very much standards based at the time, when we were all on SDI, we had a couple standards that the entire industry supported and we all worked towards. Now, as the industry started moving towards IP, as a legacy of how we've always done it, the industry wanted some standards. And also, there are some requirements because we still had to do this on hardware. Processing video and audio not so much, but definitely processing video is extremely computationally intensive. And for the longest time, not up until probably about 10 years ago, we still had to have hardware, FPGAs, ASICs, and things like that to be able to create and modify and transport the video and audio. And so when we started doing IP, we still had to have hardware in the equation to do the conversion from SDI to IP or to be able to process the IP streams in a real time manner. So, because hardware had to be in the equation, you had to have a set of standards because it's incredibly hard to make a hardware extraordinarily dynamic and extremely flexible to be able to support any standard that's out there. It's extremely expensive and completely cost prohibitive. So the industry settled initially at 2022-6, but in the end, it's went with SMPTE standard 2110. And that was a single standard that allowed for uncompressed, very low latency, very high quality video, audio, metadata to be transmitted and processed in an IP domain. And because we had that one standard, any legacy hardware manufacturer or any manufacturer that required hardware for the workflow were able to build towards that standard that gave everybody a common interface to be able to exchange media with.
Mm-hmm. So early in the transition, why did some like lift and shift attempts to move workflows to the cloud fall short?
Well, it's a couple of things really. Part of it, well, I don't want to blame it on the standard of 2110 because 2110 did exactly as it was designed to do, and that is to allow media workflows in the uncompressed, the low latency domain to exist. And the catch is with 2110 is this is extremely high bandwidth and not terribly software friendly because the amount of bandwidth that it requires to be able to use commoditized infrastructures, to be able to use standard servers and so forth. So what we saw a lot of vendors do is they took a lot of their traditional hardware-based solutions that was a server with some dedicated hardware and software running on top of it. And their goal was to be able to lift and shift that software into away from that hardware interface, away from the proprietary hardware that may have required SDI or that may have required a special network adapter to do 21 and push that into the cloud. The catch is they just took software that was never architected for a cloud architecture, that was never architected for high availability architectures and things along those lines. And they just took that software, they lifted it out of the old boxes, they shifted it into the new domain and said, boom, done, we're out. And although it functions fine, it's incredibly inefficient. And there's a lot of legacy support in there that the industry doesn't need anymore. So now you have a software solution that, although functionally works, it didn't add any new workflows, it didn't add any new features. It just removed that physical interface from the equation, which, don't get me wrong, is important. It got away from that SDI infrastructure, potentially gets away from this very high bandwidth, heavy 2110 infrastructure, but it's still software that is written to be in a legacy system that is not in any way made to be more efficient for modern architectures.
So basically, um, there are still people out there that are still relying on the hardware centric solution type, right?
Mm-hmm.
Which still creates challenges for them, even with the adoption of, IP, right?
Well, yeah,
So,
exactly. Like if there, you'll see with a lot of vendors who traditionally had FPGAs doing stuff, they're able to port some of that functionality to GPU, which fine. GPU is fantastic if you do that in a standard bare metal server, but GPU in the cloud is an incredibly expensive instance. And for some workflows, it might actually not even be needed because if you optimize the code, if you optimize the infrastructure, and you write software solutions designed to do that simple task it needs instead of what it always used to do, you can maybe find that you can make your code significantly more efficient and not have to rely on some things like not like GPU. Now, granted, there's definitely places where GPU helps, like frame rate conversion and things along those lines. There's definitely areas where GPU makes a lot of sense. But so many vendors doing the lift and shift model relied on very heavy, extremely computationally effective ineffective instances to be able to do this lift and shift, kind of still gives them the hardware centric solution because it still requires a ton of compute. And again, I mentioned this earlier, it doesn't actually buy any new features or functionality. They just lift and shifted their hardware centric solution and now moved it to IP. So you just require more compute now instead of having to do FPGA and hardware on the back end.
Okay, so what role would compressed workflows play in
Ah,
addressing cost and bandwidth challenges based compared to uncompressed 2110
so
workflow?
compressed workflows, I'll be as aggressive as to say that this is where the industry is going to be in 5 to 10 years. We're going to look back in 5 to 10 years and we're going to say, hey, remember those SDI days, or hey, remember those 2110 days? I'm not saying that 2110 is going away, but I'm going to say that the industry largely is going to move away from it. Because what does compressed workflows do? Well, you look at a 2110 camera signal, 1080p, it's a 3 gigabit per second signal. 3 gigabits per second for one input. That's an insane amount of bandwidth, right? It's also incredibly hard to transmit that video anywhere unless you happen to have an insane amount of bandwidth. We're talking hundreds of gigabits of bandwidth. Because if I want to take one 3 gigabit signal from a remote location and get it to the cloud, I have to have a huge pipe, and it's got to be very low jitter, very low latency, things on those lines. It actually has significant operational considerations to move these very high bandwidth, low latency, uncompressed workflows around. And the industry has always been very weary of using anything that's not uncompressed because it gives you areas of interoperability problems when you're doing hardware. You know, if I've got a JPEG, let's go a little older, let's go J2K, maybe I have a J2K compressed stream. I can't use that in a device made for 2110. Or I can't take a 2110 device and use that in a JPEG XS or JPEG J2K stream unless the hardware happened to have a little bit of flexibility built into it. So
So with those multiple codecs then and transport method, with those all those different codecs and transport methods, like what uh, and they're all in use today, right? So how are the
mhm,
broadcasters choosing the right combination for their specific operational needs then?
that's the cool part is once we have the availability to use compressed workflows, which we do, that opens up a lot more flexibility into the workflows. Now, if you want to have a studio that's going to be very high quality, very low latency, 2110, done, it's there. But maybe you want to have a commentator that is remote, maybe at a different studio in a different city. You can compress that signal using, let's just say, an SRT, very high bandwidth, 40 megabit 1080p SRT stream. That 1080p 30, 40 megabit SRT stream is going to be visually in, you would not be able to tell the difference between that and the uncompressed 2110 at home.
For
But
most people, right?
I would actually
Almost
argue
everybody,
for
right?
almost everybody, because remember, by the time it gets home, it's compressed again by the time it gets home, right?
Right. Hmm.
So, but because you can have talent in a different studio, in a different physical location, using the compressed stream and some of the workflows that compressed allows you, while you're also merging that into an uncompressed thing at a different studio, that just bought you a lot more flexibility. Now, you
Hmm.
think about doing a news production or sports production where you can potentially have reporters and anchors and commentators and live shots and gear all over the world, where some are coming in on SRT high bandwidth. Maybe some of them need to come in on wrist, very low bandwidth, because that's just what the connection allows you to do.
Hmm.
Or maybe it's NDI, because that's just what that individual contributor happens to be using at the time. So once you move into this mix of compressed and uncompressed domains, that really buys you a lot of flexibility on being able to design the workflows for the most economical and the most engineering focused
Hmm.
and efficient manner you possibly can.
So how have these hybrid workflows, blending on-prem and cloud environment, how has that reshaped the industry's approach to production and distribution then?
It's been really interesting. It actually makes it's an ultimately an engineering it's ultimately an engineering design, but it brings significant financial equations into the design element. Because can you put an entire production in the cloud? Sure. Now, if you're just going to do a 30-minute production or an hour long production and that's it, and you're going to shut it down, it actually makes quite a bit of sense to do that purely in public compute like AWS or Azure or GCP or whatnot. I'm trying to be careful with how I use cloud because people tend to misuse that terminology. Um, but if I'm a network and I'm going to be producing content 24/7, 365, it doesn't make a lot of financial sense to put that into public cloud because the public cloud will always be more expensive on a 24/7, 365 than it would be to build that same infrastructure at your own facility. So, what we've seen a lot of customers are doing now is for the parts of their productions that are running 24/7, 365, things like master control, distribution, OTT, VOD, put it on prem if you want.
Mm-hmm.
Um, but if it's going to be an occasional use, hey, I just need to pop up and I need to do a special production for, let's just say it's the Olympics, for example. The Olympics is a fantastic example where NBC has a facility where for roughly 1 year and 8 months, they use on-prem with the productions they use 24/7, 365, and that's it. But then all of a sudden, every 2 years for the Winter Olympics and then 2 years later for the Summer Olympics, they have hundreds of more feeds, dozens of more productions that they have to do very quickly, but they're only going to do it for a couple months. Spin it up for the Olympics, spin it back down. So that's a wonderful example of how you can have on-prem equipment that handles your normal infrastructure, your 24/7, 365 equipment. But we need to spin up a production, spin up workflows to be able to handle more productions and handle more feeds, more media, or whatever you happen to be doing at the time. Then that will allow you to burst into the cloud or burst into public compute. But
Yeah.
these type of workflows only work once you move into a pure software domain. As long as you got hardware in the equation, those systems don't scale the way you need them to.
Yeah. So, having said that, right, Tag Video Systems been IP native, 100% software since the beginning for the last 15 years, right? So,
Mhm.
and we're kind of at the forefront of supporting these hybrid workflows. How do you, uh, how do the modular and scalable architectures help broadcasters future proof
See, that's
their
the cool part.
operations?
So a couple minutes ago, we were talking about the different codecs and how there's interoperability issues where if somebody has a 2110 facility and you want to be able to feed J2K into it, somewhere you're going to have to convert from J2K to 2110. Well, there's always cost to do that conversion. Well, now you want to add SRT into your 2110. Well, now you're going to buy more conversion to convert from 2110 or SRT to 2110. And now you want an NDI. And now you want to do RIST. And now you want to do H.264. And now you want to do H.265. And maybe you got some legacy MPEG-2 in there. You can see where the possible permutations of different feeds, transports, codecs, and everything can grow immensely. And as long as you have hardware, you're always going to have to deal with a layer of conversion to convert from one format, one transport to another format, another transport, and so forth. So tag is actually quite exceptional because if it's IP and used in the media ecosystem today, we support it. So if you want to have a monitoring, probing, and multi-viewing solution that mix and matches 2110 and SRT and NDI and WebRTC and H.264 and H.265 and MPEG-2, I'm being a little ridiculous here by running through these, but by the way, this is still a smaller subset of what TAG can do. We support it natively today.
Yeah, so you're saying Tag is enabling this flexibility for the broadcasters that are working across this multitude of codecs and transport methods.
And that's the best part is we don't, because we're a native IP, we don't need to add this extra layer of conversion. But also with all these other streams that the broadcasters are bringing in today, the SRTs and 2110s and NDIs and everything, each of those streams has its own set of complexities. You know, if I'm bringing in a SRT stream from the other side of the world over some pretty sketchy internet, I need to have the ability to monitor that transport stream to make sure that my transport isn't starting to break down or where I'm getting really high bit error rates or my jitter is getting really crazy or whatnot, which is fine when you're bringing in one feed.
Right.
But what if you're bringing in 500? How do you have somebody monitor that? But also, at the same time, you're taking in 2110, and now you have to be able to monitor PTP on every source. And at the same time, you have JPEG XS, and you have to be able to monitor how that transport stream is working. So that's where tag comes in, is because we can natively look at all of these feeds in their native space in their domain without any conversion, we can allow the customer to scale as big as they want, and we will monitor all the feeds for them. We'll monitor the quality of the transport. We'll monitor the quality of the audio and the video and the metadata and all that. This type of workflow is where the industry is going towards. But you can't do it unless you have a system that is IP native, but more importantly, is able to support all the codecs and all the transports that the customers need. And that's what TAG brings to the equation.
So basically, you're saying tag is uh, set apart from, or most vendors anyway. Other vendors like us are probably doing the same thing where we're simplifying workflows while minimizing uh, vendors or blocking into specific vendors or solutions, right?
And that's something that, so being able to avoid being locked into vendors is something that's been very passionate with TAG, because we have the ability to work with open standards, but we also have the flexibility to work with a lot of newer, I would say proprietary. The other vendors call them open, but you still have to pay to be on part of their platform, their proprietary platforms. So when you have a properly architected software solution, you can leverage the open protocols when you need them, but also if the customers need it, the customers require it, and this is the path they want to go down, we have the ability to adapt to proprietary broadcast vendor solutions, because we're seeing that now. We're starting to see a lot of legacy vendors who are trying to protect the legacy revenue by creating their own platform. They're calling them open because other vendors can be on them. What they're not telling the rest of the industry, of course, is that if another vendor wants to be on that platform, they've got to pay them 15 to 30% of their revenue.
Mm.
So thankfully with TAG, that actually just becomes a commercial exercise, because the platform is able to adapt to these new standards, these new protocols, and even these new proprietary platforms as they come out. And if our customers want it, if the customers need it, we can adapt to it. But again, it becomes a commercial discussion on how we're able to make that work. And the reality is that's where you want to be. You want to have a solution that is so flexible that can adapt to what the customer's needs are. And then we can kind of work on the commercial T's and C's. That's a lot easier than having to reformulate the entire product just to add some more functionality.
So I don't know what the exact statistic is, but let's say half or more are still uh, companies are still relying on SDI. So
Mm-hmm.
what? How do you see that transition to going to hybrid workflows evolving in the next couple of years,
That
or
transition is going
even
to be
more?
fast, because it's interesting. Even though the industry has been IP now, especially with 2110 since about 2016, moving to IP has been rather cost prohibitive. The first couple of years, it was way more expensive to do something in IP than it was to do in SDI. But if the customer had the requirement, it was worth the money, and they did it. What we've seen over the past, I would say 3 or 4 years, is especially with dealing with compressed in the compressed domain. So NDI, SRT, RTMP, RIST, things along those lines, that the cost of the software and the cost infrastructure now is parity or cheaper than doing
Mm.
it in SDI. Because remember, you don't have to pay for the hardware. You're just paying for the software licenses and whatever commoditized infrastructure you had. And the commoditized infrastructure is getting faster
Mm-hmm.
every month. And so as it gets faster, you need less and less of that hardware to do the same productions. So I would say in the next probably 4 to 5 years, you will see the industry, not just the tip of the pyramid industry, not just your huge content providers, but you're going to start seeing your smaller to medium sized content creators go entirely into the IP domain. And honestly, you're seeing a lot of that now, where a lot of the smallest producers are doing stuff in the IP domain, and the very tip of the top pyramid is doing stuff in the IP domain. It's everything in the middle. And we're going to start seeing this collapse farther and farther and farther in the next 4 to 5 years, to the point when uncompressed 2110 will almost entirely go away, except for some legacy installs. SDI will absolutely go away, and it'll just become software running on generic compute, running compressed workflows to be able to connect workflows.
So, what would you advise broadcasters who are still hesitant to make that leap from, or make the leap to software, uh, or native or hybrid workflows?
That's an interesting discussion that we've been having with our customers, where some of our customers that have legacy SDI infrastructure are actually considering skipping 2110 and going to wait a
Mhm.
year or two for compressed workflows to get a little more ubiquitous, and then they're going to move straight into compressed.
Mhm.
We're seeing that quite a bit. But we're also seeing customers that have just spent 5, 10, 15, $20 million on 2110 infrastructures say, hey, I've got this infrastructure. It looks fantastic. It's very low latency. It scales fantastically. I want to be able to continue leveraging this. But I realize that compressed workflows are the future. So I need tools that support both the uncompressed IP domain that I have today, but that'll also give me a demarcation point, an area to jump into the compressed workflows and be able to mix the two as the workflows see fit.
Mm. So, what does that future look like for broadcast workflows, in terms of technology, flexibility, customization, name it?
You're going to see this is actually going to be really fun because once you got away from this hardware domain, you have to understand to make a product in hardware is extremely expensive. You have to build the board, you have to prototype the boards. You have to design the boards, and you have to prototype the boards, and you go into manufacturing, and then you have to support them and QA them and everything. So anytime you wanted to do something in the hardware domain is incredibly expensive. But once you're into software, you can have pieces of software that just do one task. I just want to be a frame rate converter, or I just want to add a little HTML graphic to the bottom of my video, or I want to do some HDR conversion or whatnot. The barrier of entry is much smaller for companies to be able to do that. Now, it's still an effort, don't get me wrong, but it's smaller for them to do that. So the part that I see as the future is you're going to start seeing workflows that consist of products made by a smaller or larger amount of small companies that can be
Mm.
stitched together to create the workflows that the customers need. Because you no longer need the $10 million infrastructure to be able to do this, because that's what you had in hardware. You can buy the best of breed. I can take a piece of software from this vendor because this is what I need. I'm going to stitch it together with the monitoring and probing and visualization that Tag can give me. And then
Mhm.
I'm going to stitch into some video processing downstream to be able to do this, which Tag will also monitor and so forth. You'll have the ability, and this is, as I see the future of the broadcast workflows looks like, is the ability to take software solutions from many vendors. Some of them might not even exist right now, or some of them, like Tag, have just become very dominant in the past couple of years. Stitch them together and create the workflows that the customers need to make in a very non-traditional manner, but it's exactly what works, and it's the future of the industry.
Great. That's a great conversation. So, the only thing left from that whole conversation and what you just said prompted me to think. So, interoperability is one of the
Mhm.
most important things to be thinking about, and I think Tag has already accomplished that and proved that, with many customers and many vendors, right?
Yep. Yeah, the only people that are going to be squeaking and squawking about interoperability are your legacy hardware vendors,
Mm.
because they're legacy hardware vendors. That's what they've always done. And as they're creating their proprietary solutions, open but proprietary solutions moving forward, they're still going to be kind of squeaking and squawking about that because that's what they have to do. They're trying to preserve
Right.
their legacy revenue. The reality is if you have a properly architected software solution, you're able to adapt your software to whatever level of interop you need it to become.
Perfect.
It's the future of it.
Great. Great conversation, Robert.
Yeah.
Appreciate it.
Thank you for the time.
Thanks so much.